Q6905. When diverting to an alternate airport because of an emergency, pilots should A. Rely upon radio as the primary method of navigation. B. Complete all plotting, measuring, and computations involved before diverting. C. Apply rule of thumb computations, estimates, and other appropriate shortcuts to divert to the new course as soon as possible. The correct answer is C. When faced with the need to divert to an alternate airport in the event of an emergency, pilots should prioritize swift decision-making and take immediate action to ensure the safety of the aircraft, crew, and passengers. In such critical situations, relying upon rule of thumb computations, estimates, and other appropriate shortcuts becomes crucial. Completing comprehensive plotting, measuring, and computations before diverting may consume valuable time that could be better utilized in executing the necessary course change promptly. By employing rule of thumb computations and estimates, pilots can quickly determine the adjustments required to navigate towards the alternate airport. These shortcuts are based on their experience, training, and knowledge of common aviation principles. They allow pilots to make informed decisions swiftly, without sacrificing accuracy or safety. While precise calculations are essential in regular flight planning, emergency situations often demand a more expeditious approach. By utilizing rule of thumb computations and appropriate shortcuts, pilots can swiftly establish a new course of action, taking into account factors such as distance, time, fuel consumption, and available navigational aids. This allows them to promptly communicate with air traffic control, inform the cabin crew and passengers, and initiate the necessary maneuvers to reach the alternate airport in the shortest possible time. It's important to note that while the use of shortcuts and estimates is acceptable during emergency diversions, pilots should still exercise good judgment and ensure their decisions align with standard operating procedures and regulations. The goal is to balance the need for expediency with safety and adherence to established protocols. 6882. When converting from true heading to magnetic heading, a pilot should A. Subtract easterly variation and right wind correction angle. B. Add westerly variation and subtract left wind correction angle. C. Subtract westerly variation and add right wind correction angle. The correct answer is B. When converting from true heading to magnetic heading, a pilot should add westerly variation and subtract the left wind correction angle. This process helps align the heading information obtained from the aircraft's compass, which is based on magnetic north, with the true heading based on true north. Westerly variation refers to the angular difference between true north and magnetic north, with magnetic north being located west of true north in most regions. By adding the westerly variation, the pilot adjusts the compass heading to compensate for this westward shift. Furthermore, wind can also affect the aircraft's heading. When there is a crosswind from the left side of the aircraft, a left wind correction angle is applied to counteract the wind's influence and maintain the desired heading. By subtracting the left wind correction angle, the pilot compensates for the effect of the crosswind on the aircraft's heading. By following these steps and performing the appropriate calculations, the pilot can convert the true heading to magnetic heading, ensuring that the aircraft is properly oriented with respect to magnetic north, accounting for both the variation and the wind correction. 6883. When converting from magnetic course to true heading, a pilot should A. Add easterly variation regardless of heading. B. Add westerly variation regardless of heading. C. Subtract easterly variation when on a heading of 360 degrees. The correct answer is A. When converting from a magnetic course to true heading, a pilot should add easterly variation regardless of the heading. This process allows for the adjustment of the magnetic course, which is referenced to magnetic north, to obtain the true heading, which is referenced to true north. Easterly variation refers to the angular difference between magnetic north and true north, with magnetic north being located east of true north in most regions. By adding the easterly variation, the pilot corrects the magnetic course to align it with the corresponding true heading. It is important to note that this correction should be applied regardless of the heading. Whether the aircraft is flying towards a northerly, southerly, easterly, or westerly direction, the easterly variation is consistently added to the magnetic course to obtain the true heading. By following this procedure, pilots ensure that their navigation is based on the true heading, which provides an accurate reference to true north and enables precise navigation and communication with other aircraft and air traffic control. It's worth mentioning that other factors such as wind correction angles or specific compass deviations may also need to be considered when calculating the final true heading. But the initial step in converting from magnetic course to true heading is to add the easterly variation regardless of the aircraft's current heading. 6884. When converting from true heading to true course, a pilot should A. Add right wind correction angle. B. Add left deviation correction angle. C. Subtract right wind correction angle. The correct answer is C. When converting from true heading to true course, a pilot should subtract the right wind correction angle. This adjustment is necessary to determine the actual track or course over the ground that the aircraft is following, accounting for the influence of crosswinds. The true heading represents the direction the aircraft is pointing in reference to true north, while the true course refers to the actual path the aircraft is taking over the ground. Since wind can affect the aircraft's track, it's important to apply wind correction angles to establish the true course. In the case of a right crosswind, a right wind correction angle is needed to compensate for the wind's effect. By subtracting the right wind correction angle from the true heading, the pilot can determine the correct true course that compensates for the drift caused by the crosswind. This adjustment ensures that the pilot can accurately navigate the aircraft along the desired course, considering both the initial heading and the impact of crosswinds. By subtracting the right wind correction angle, the true course is determined, which enables the pilot to maintain the intended track and reach the destination accurately. It's worth noting that other factors such as magnetic variation or specific compass deviations may need to be considered in the overall navigation process. But when converting from true heading to true course, the correct procedure is to subtract the right wind correction angle to account for crosswind drift. 6885. The angular difference between true north and magnetic north is A. Magnetic deviation. B. Magnetic variation. C. Compass acceleration error. The correct answer is B. The angular difference between true north and magnetic north, known as magnetic variation, is a crucial factor in navigation. It represents the variance between the Earth's magnetic field and true north, which is aligned with the planet's geographic axis. The Earth's magnetic field is generated by the movement of molten iron within its outer core, and magnetic north is the point on the Earth's surface where the magnetic field lines converge vertically. However, magnetic north is not fixed and can vary from true north depending on the geographic location. The magnetic variation is expressed as an angle in degrees and can be either east or west. If the magnetic north is located to the east of true north, the variation is called easterly variation. Conversely, if the magnetic north is to the west of true north, it is referred to as westerly variation. Magnetic variation is essential for accurate navigation, especially when using a magnetic compass. Since a magnetic compass aligns with the Earth's magnetic field, it can provide a heading relative to magnetic north. To convert this heading into a true heading relative to true north, the magnetic variation must be taken into account. Pilots and navigators use charts, maps, or navigation aids that provide information about the magnetic variation specific to a particular location. By applying the appropriate adjustment based on the magnetic variation, they can convert between true north and magnetic north, ensuring precise course calculations and reliable navigation throughout their journey. Understanding magnetic variation and making the necessary corrections based on it is crucial for accurate and safe navigation, allowing pilots and navigators to maintain proper heading references and reach their intended destinations with precision.